Hi, it's Dr. Oscar Serelak. Today for a Facebook Live, we've got this very important conversation around iron. And iron it's very well researched, but very poorly understood, especially by a lot of healthcare workers that are in the mother care space. And certainly I've seen with a lot of doctors and specialists who really underestimate how important iron is. I'm lucky to be working in an area where we have specialists such as hematologists and obstetricians who really understand how important it is. So they're very much on the same page as I am in terms of trying to really promote iron as what I believe is the number one nutrient for pregnancy and for the postnatal period. And I'll be doing a series of talks around different nutrients as time goes on, but I thought iron would be the perfect place to start. And I always try to give minerals and vitamins a bit of a personality in terms of just trying to understand a little bit about what they do, as opposed to them being something on the periodic table that you remember from chemistry at school, and that's kind of the end of it. So, iron has two superpowers in terms of the things that it can do. One is it can carry oxygen, which is obviously very vital, but oxygen's quite a risky thing to be carrying around. So we'll talk a little bit more about that later. And then it can help shuttle electrons from A to B, so part of the transfer chain. And so again, that's a very important thing for any energy production within the body. And so most of us have seen Iron Man, which is the Marvel sort of movie, and he's got this little thing in his chest which is called the arc reactor. And I kind of see iron a little bit like that. It's really what helps stimulate life and give Iron Man, or in this case Iron Mum, her superpowers in terms of energy and a number of other things. So let's talk about what does iron do, because it's not a simple single task that it does. So everyone knows that iron is what makes our blood red, and it's a primary part of hemoglobin. And what's interesting about hemoglobin, a couple of things. One, plants have a type of hemoglobin called chlorophyll, and we all know that chlorophyll is what makes plants green, and it's very much associated with photosynthesis and oxygen sort of utilization. The molecule of chlorophyll looks very similar to hemoglobin, but in a plant you have magnesium in the middle of the heme ring, and in all animals you have iron. And so this is a very ancient part of our sort of physiology, and the reason why you've got hemoglobin, which is this massive molecule, and it's just carrying oxygen right at the edge, and oxygen is a bit like a grenade. Really important for the mitochondria to be able to do their work in terms of energy production, but if you drop that oxygen in the wrong place, boom, it goes off, and you have oxidation, this rusting, and that again just causes damage. So oxygen is life, but it also is what causes death through this oxidative sort of state. And so it's but iron does many things apart from just carrying this oxygen around. So let's talk about some of those, because I think when mothers go to see their specialists, they're often just looking for anemia, which is low hemoglobin, and they're not necessarily really looking deeply at iron stores. So I'll go through the list quickly of what sort of iron does, but it's important to understand that it's involved with many things. It's involved with cytochromes. So cytochromes are these special enzymes mainly found in the liver that are really important for detoxification. They're also really important for energy production within the mitochondria. because of that electron transfer chain. So they're a key part of that machinery, and they're really important for another detoxification enzyme called catalase. And catalase is super important for getting rid of a lot of the oxidative molecules that come from gut digestion. So when people are talking about toxins, most of the toxins that we're dealing with are derived from our gut and from digestion. And then we have things from the environment as well, but it's such a key. And so you can see if you're getting low in iron, all these things are going to get affected. Iron is also very important for hormones. So it's very important for thyroid hormone production through perioxidase. And it's also really important for getting rid of estrogen and healthy estrogen metabolites. So if you're struggling with iron deficiency during pregnancy, it can also be affecting your thyroid hormone production. So there's a double whammy around lethargy potentially there. Iron is also super important for the brain, and in the brain, iron is important for helping convert tryptophan into 5-HTP. So that's basically around serotonin and melatonin. So again, serotonin very important for concentration, mood, melatonin very important for sleep. So again, another key role that iron has. It's also really important for converting tyrosine to dopamine. And dopamine is around reward and pleasure and around executive function and concentration. Again, and it also has a very essential role in our stress response system. And so iron is a key regulator of that. It's also very important for the immune system. The conversion of cysteine to NAC requires iron. NAC is one of our frontline firefighters for so many aspects of immune function and viral infections as well. And people with low iron tend to be more prone to infections. So both the severity and and how long an infection is going to last. Another key thing that iron does that's not well understood is around this key regulation of something called PPAR gamma. And most of the research around PPAR gamma has been around obesity, but PPAR gamma is actually really important for insulin sensitivity and reducing inflammation. So if your iron is low, it's going to affect that, and you're potentially more prone to weight gain in the future as a result. So all pretty big things in terms of what iron does. So it's a multifaceted nutrient. And this is why I consider it my number one nutrient, mainly for antenatal, but also for that postnatal period. So we're going to talk a little bit about iron digestion and absorption, and then move on into its role in pregnancy. So we all kind of know that there's sort of heme iron, animal-based iron, and non-heme iron or plant-based iron. And they're quite different. So the animal iron is much more easily absorbed. In fact, it's 5 times easier to absorb animal iron than it is plant-based iron. And you might have heard that if you're taking iron, you need to take vitamin C, and it helps with absorption. That vitamin C is mainly for that non-heme iron. You don't need it for the heme iron. So if you're having any plant-based iron, I think this is where the things that will help change the iron form. The vitamin C is really useful for that. And there's iron is it's complicated because if there's too much iron in your system or too much iron in your gut, parasites and infection love that, or they need that iron for their processes. It's a little bit like mosquitoes. The only reason why mosquitoes bite humans is because the females need iron for their pregnancy, and so and so many of these parasites that can live in our gut, or many infections that need to survive, or that are trying to survive in us, need iron. And so the body's got this very complex regulation mechanism of, if there is inflammation or infection, we will sequestrate iron. That means take iron out of its free form and put it into storage, and then we'll actually slow down absorption of iron in the gut. This is a really crucial thing, because if for whatever reason, especially during pregnancy, there is some inflammation going on, we're going to have the iron levels look artificially high, and then we're going to have a reduction in iron absorption. And this is one of the things that frustrates me hugely, is when you have a look at most of the iron that's available out there for consumption for pregnancy, it's of a form called iron sulfate, which increases inflammation through interleukin 6 and actually down-regulates your absorption of iron. It's almost as if the body perceives that iron signal is coming from inflammation, and then the body down-regulates iron absorption. You need higher amounts of iron sulfate, and this is where you get so many of the side effects of iron supplementation. It's usually through these types of forms, which is really paradoxical, because you're having to increase the amount of iron you're taking orally to have less and less absorption over time. And then and so taking something like iron sulfate might really help for a month, get your iron levels up, but then it's actually affected you for months afterwards in terms of being less able to absorb iron. I've got a question here from Jody around iron infusions. I'm definitely going to talk about that, because that's one of my favorite things to do to help with recovery, is an iron infusion, if levels warrant that. So so we've got this key regulation around sort of iron within the body, and we can only really absorb iron in the upper part of the small intestine, called the duodenum. And so the body doesn't really want to absorb iron anywhere else in the digestive tract, and it actually wants to try to make it non-usable, especially for gut parasites. And so the idea is that that iron is absorbed in the top part of the gut, and then you, through things like lactoferrin, try to bind the iron so it's only available for our healthy bacteria, not for parasites. But we can't then absorb that iron later on. And so there's a very sort of fine balance, and we really don't want to be upsetting that with taking the wrong type of iron, or having inflammation that's not being managed during pregnancy. And so another thing in terms of, we have iron receptors for that plant-based iron and for animal-based iron side by side. Easier to absorb the animal iron, and we can only absorb in that top part of our digestive tract. And so if you can't liquefy that steak that you've just eaten, or you've eaten sort of something that needs to be very well cooked from a plant point of view, that's got plant iron and it's in its raw form, or lightly steamed, for example, it's a lot harder to get the iron out of that, and then you've missed the opportunity. And so having a certain amount of iron in your food doesn't necessarily that mean that's going to translate into iron in your body. So we'll talk a bit more about details around that, but it's I think it's important to understand the regulation of around iron, and then the absorption, and we need to really be able to digest our iron, or our iron-rich foods well. A lot of us have digestive issues anyway. A lot of us can develop digestive issues during pregnancy, and so a system that's struggling can be further compromised. Just one more thing to say around iron absorption is around oxalates. So some of you may have heard around oxalates being something that's potentially harmful within foods, and oxalates, when we take a lot of them in our diet, say through raw green leafy smoothies, for example, that's going to bind iron, and so we can't absorb iron. So it's this idea that a healthy food can then have effects on other parts of digestion. So let's talk about pregnancy now. So we've talked about what does iron do, why is it important, a little bit about the absorption and digestion sort of side of things, and so why is iron such a big deal during pregnancy? The average body has about 3 to 4 grams of iron when you kind of measure and most of that's in hemoglobin. Then we have some in muscle. Then a lot's locked up in storage, and a lot of these enzymes that we sort of talked about being really important. An entire 9-month pregnancy needs about 1.2 grams. So when you're looking at if the body's only got 3 to 4 grams, 1.2 grams is a lot in terms of what's required for a healthy sort of pregnancy, and 40% of mothers leading into early pregnancy are already iron deficient. So that is already putting the mother on the back foot in terms of her ability to have a happy, healthy sort of pregnancy, and really makes that iron much more important. Now we'll talk a little bit about sort of iron sort of blood test, but we might sort of do that now actually. So one of the things that I find very, very frustrating, especially with all the research that's out there, is that I have a lot of mothers coming to me telling me that they were only slightly anemic or only slightly iron deficient, and then not actually given any advice or support or supplementation around that. So that I find extremely frustrating, because having anemia or low iron is actually quite late down the stage of that sort of iron sort of balance, and so we want to catch things as early as possible, as opposed to waiting for there to be sort of a real problem with potentially some long-term negative effects. So ferritin is the main thing that we're looking at with iron storage, and ferritin is almost like the long-term storage. So it's like money in the bank. You can't necessarily it's not that easy to take withdrawals from the bank, but it's there. And the short-term form of iron, the money in your wallet type iron, is called transferrin. And so essentially, you're looking at whether you're anemic, so your full blood count, you're looking at the size of your red blood cells, and the mean cell hematocrit. They're things that are kind of useful. And then the iron studies looking at ferritin, and then looking at transferrin saturation, which is a percentage. So in Australia, we use micrograms per litre. Anything below 30 micrograms per litre is considered to be deficient. And with the transferrin saturation, you really want that to be between 30 to 40%. If it's below 20%, you've got an iron problem. If it's below 15%, you have got very significant iron deficiency, even if your ferritin looks okay, because your ferritin can be artificially raised if you have infection or inflammation. It's called an acute phase reactant, and what the body again is doing is that it's trying to sequestrate this iron into long-term storage, so these bugs or things that are causing the inflammation don't have access to that. So it's taking it out of the wallet and putting it into the bank, just for protection, if you like. And so, and part of what's almost a bit ridiculous for me is when you're looking at levels of iron. So not all labs do this, but a majority of labs will have that you have to have 95% of the population within the normal range, and so only 5% will be considered to be deficient, and they're having to move the goalposts as we become more iron deficient as a culture and as a society. But the research has shown that 25% of females of reproductive age are iron deficient. But if only 5% are allowed to be called iron deficient, you have a whole whopping 20%, 1 in 5 women of this age group that are iron deficient, and they're told their levels are fine. I mean, how ridiculous is that? So it really gets me very upset and angry to see, I suppose, how superficially the medical industry often will look at these kind of things rather than going, well, iron's a really big deal. We know what the optimal levels are. We know around this idea of just because things are in the black and not in the red, in terms of when the results get sort of downloaded, there can be a significant issue there. So this is why it's good to be informed as a consumer about what those numbers are, and you can have a look and go, oh my goodness, my transferrin saturation is not in the ideal. Do we need to do something about that? So a couple of questions here. So Wendy's talking about improvements in anxiety and panic attacks from correcting iron deficiency. So this is definitely part of the brain aspects that the iron does. But no, and a tired brain is also going to have a lot of problems with regulating anxiety and mood. So iron increases energy, but it also really helps with serotonin, melatonin, dopamine, and indirectly noradrenaline. So it's iron in the brain is super important for well-being, and then iron in other places such as the liver also has lots of benefits. So I wholeheartedly agree there. There is quite a bit of research showing association, but I haven't seen that many large controlled trials looking at iron supplementation specifically around that. Do you think women taking antacids for reflux in pregnancy will affect your ability to absorb iron? That's a great question. We'll talk a little bit about that with sort of supplementation, but the idea is you're trying to increase your acidity with meals, and then trying to, if you're having reflux, decrease acidity in between meals. So antacids shouldn't necessarily affect your ability to absorb iron, but whatever's causing the need to take the antacids could be affecting. And so in terms of that reflux or poor digestion, again, knowing that we can only absorb food-based iron in that first part of the small bowel. And Lisa here is asking, when pregnant, what levels do you like to see when looking at blood results? So so a couple of things that happen. One, we have a dilution, so especially third trimester, there's 25% extra blood volume, and so you can get a dilutional effect. So that can make the hemoglobin and iron levels drop, just because they're looking at concentration. And if we already know that 40% of mothers are having iron deficiency before starting the pregnancy, now I really like to have the ferritin around 70, and that means that the mother's got about 0.5 gram of iron in long-term storage that she can take withdrawals from for the placenta, for the baby, and to be honest, I don't see that level very often. But that's definitely what I'm happy for. In my clinic, if ferritin is below 25 micrograms per litre, that's my unofficial cutoff for suggesting an infusion. Below 30, I'll often sort of have that discussion, and between 30 and 50, I'm often talking about supplements, diet, and ways to sort of maximize that iron. So, and again, during pregnancy, in the 3rd trimester, a mother's need for iron goes up 7 to 10 times above baseline when she's not pregnant. So again, in that 3rd trimester, the baby is making most of its blood, and so the fetus will just take whatever it needs. There's actually research showing that the lower a mother's iron is, the more upregulated the placenta becomes to take iron from the mother. So it's almost the placenta's sensing iron deficiency and it's trying to grab as much as it can for the baby. And again, what typically can happen in the 3rd trimester is, with the combination of that, with the dilution, you can sort of see a lowish iron suddenly crash to a very, very low iron level. And so that's, I think, really critical. And I'm amazed at how often iron isn't tested for. Maybe it would be done at the beginning of the pregnancy, and that's the last time it's sort of done. And then they're just looking at hemoglobin as their kind of marker. And I think every blood test, it's a very cheap test to do. The research is showing that it's so important in terms of outcomes. Kristen's writing here, I had one woman start pregnancy with a ferritin of 102, which is, if the transferrin saturation, like I said, is at 30 to 40%, that's a really good level. She didn't supplement with iron throughout, and at 36 weeks it had dropped to 22. So so even just through food, and most of the antenatal supplements don't have iron, or they will have an option of an iron supplement or an iron-free supplement. We'll talk about the iron supplements in a moment, because there are a few options, and it's more about which ones to avoid, and then these are the ones that are more sensible to be taking with what we've already sort of talked about. So another very interesting thing, and I don't know the mechanism exactly, but a mother can absorb 50% more iron in the 3rd trimester through her diet. And so I presume it's related to some of these other protein regulators and iron receptor upregulation. But nature's design obviously is that the baby needs way more iron in that 3rd trimester, and the mother can absorb a lot more iron. So it's a harmonious system when it works. So let's talk a little bit about some of the symptoms with low iron, and then some of the risks with having low iron for the mother and for the child. So some of the common symptoms with iron deficiency include fatigue, it includes poor exercise tolerance, shortness of breath on exertion, and when it becomes more severe, you can get things like palpitations as well, and especially when anemia is there. We often see sort of poor concentration, easily overwhelmed, and mood problems. And I think a lot of that has to do just with the tired brain, and then the brain slightly compromised in making its neurotransmitters. Physically, we can sort of see things like brittle hair, brittle nails, and in postpartum, it can be part of what contributes to hair loss as well. A really interesting symptom that I see that isn't that well documented, but there's a reasonable amount of research around understanding this, is especially in the third trimester, is restless legs. So restless legs when a mother's trying to sleep and she's already got a big belly and having problems sleeping potentially in the third trimester. These fidgety legs, restless legs at night time can be really problematic, and everyone's thinking about magnesium. Everyone's forgetting that iron is also really important for that symptom. So I'm always on the lookout for that. When I'm examining mothers, what I'm often looking for is what they call pale conjunctiva, which is essentially the white part of the eye can start getting a bluish tinge to it, regardless of the color of your iris. So the conjunctiva becomes pale, the white part, and then you can start getting this sort of bluish tinge. You can sometimes see cracks in the corner of the mouth, and even though that's often related to B group vitamin issues, iron can definitely be part of that. With the tongue, with iron deficiency, you can, especially with severe iron deficiency, you can see that the tongue gets quite red and raw. That's quite a late sign. And also a late sign is spooning of the nails. It's called chylonychia, and it's actually this, rather than the nail being quite convex, it's actually spoon-like. But again, it's a very late sign. Another common sign in sort of the early iron deficiency is loss of color in the palmar creases. So as you can see with my hand, you should be able to see a nice defined color at the base. And people who have iron deficiency, you often see that line, especially when you're kind of spreading it out, is quite pale. And again, that's another clue around iron deficiency. And these, if a mother's already struggling, you just can't afford to have low iron because of the effects on energy, exercise tolerance, brain function, and detoxification. Kristen's asking, what's the mechanism behind iron causing restless legs? I think it has to do with myoglobin, which is the colourful pigment inside muscles, and it may have to do with the sort of the detox pathways. It's been very well correlated. I don't think the mechanism's 100% certain around that though. So part of the reason, so low iron is implicated in things like depression and maternal emotional struggle postnatally, but low iron leading up to the birth time is also associated with increased bleeding complications, especially with the natural vaginal delivery. And there's this paradox of the lower your iron, the more your bleeding tendency. And so for me, this should be maybe the reason, or the primary reason, why in the hospital system they shouldn't really be tolerating low irons, rather than just saying, oh look, we'll just top it up later if you sort of need it, knowing that many mothers don't necessarily return for follow-up after the birth of their child. For the child, so if a mother has severe iron deficiency during pregnancy, the child can have lower brain levels of iron, and there's good research showing that even 10 years after the birth, and even after the child's recovered their iron very quickly in that first year, that there are long-term potential issues around concentration and memory for that child. So again, not a happy fact, but it's just something, again, why we need to be taking this sort of so seriously. And for me, that's quite profound, something that can have such long-term sort of issues. And to be honest, I don't think many of these issues have been looked at long-term. So medicine is very much about the here and the now. It's very hard to do this research to look at what happens down the track with these things. And we also know that breast milk is very low in iron, and so in America, if a child is exclusively breastfed for 6 months, they actually recommend iron supplementation from month 4. That's not necessarily the recommendation in Australia. In America, they have iron fortification of foods, which we don't have in Australia. They seem to be taking it more seriously than we are. But I think they've identified that iron fortification of foods actually saves the economy lots of money down the track, and that's, I think, what motivates that as into legislation. And this is part of the reason why you can't exclusively breastfeed a child beyond the age of 6 months, because their iron levels will slowly drop from birth. They're not getting much iron in the breast milk, and then from 6 months they really need to start, as they're becoming more active, as they're starting to become bigger, they really need that iron. And so the first foods that are often introduced for babies are recommended to be iron rich, and that's the reason. So let's talk a little bit about let's talk about sort of how do we know iron is low, we know what iron levels we're kind of looking for, what do we do to get iron up? And so if a mother is really low in iron, and again, ferritin below 25, I'm really quite insistent around that. I'll recommend an iron infusion, and the types of iron that I recommend are iron sucrose and iron carbo, the maltofer, so maltofer, and they're the common ones that you'll typically see in GP practices. In hospitals, they're still using iron polymerase, which is an older type of iron. Definitely don't recommend that. And a one-off infusion, and the reason why I prefer the iron sucrose or Venofer is that you have very low allergy rate, 0.3%, and most of the time you don't need any intervention with that allergy, and mothers can feel much better the next day. Whereas some of the other types of iron, a mother can feel quite rubbish for a few days before she then starts to feel better. And just because the body then has to take this slightly inflammatory iron and then put it into storage. Whereas the iron sucrose is it's very easy to put into storage. In terms of iron supplementation, what's interesting for me is that there's been a lot of research over recent years about what types of iron is better, and the superstars of iron include iron bisglycinate and iron fumarate. Most irons that you sort of see out there are iron sulfate, and again, this has the problem of not only being harder to absorb, but increasing the perceived inflammation going in the body, increasing interleukin 6 and down-regulating iron absorption. So there's a real paradox that we want to avoid there. You don't get that with the bisglycinate and fumarate forms, and recent research shows that if you dose every second day, not every day, you'll actually get more iron into your system, which seems like that wouldn't be possible just from a numerical point of view. But what happens when you take it every second day, you're not having an even amount in your supplement every day, and your body can upregulate its iron absorption. again, because the body's getting a signal that it needs to do that. And again, not many mothers I hear are recommended that, but every second day you actually can speed up your iron recovery, if you like. And if you do that, you don't actually need that much. Often 20 to 30 milligrams of an iron bisglycinate or fumarate is enough to really help you see improve your iron levels, whereas typically with the iron sulfate, you might need 75 to 150 milligrams, and the results aren't as good, and then you're down regulating your iron absorption. One more thing I was going to say about sort of iron supplements, and there's research also showing that 30% infused iron lactoferrin, which comes from cows, is as good as any of those top iron supplements that I've talked about. And again, those iron supplements plus this lactoferrin have very little in the way of gut side effects. And the main reason why a mother doesn't continue her iron supplements or non-compliance is because of the side effects she's getting. Nausea, constipation, and it's because it's not the right type of iron for her. Rather than persevering with this quite rubbishy type of iron, it's really important that she switches to an iron that she can tolerate and it's actually going to do the job properly. So let's talk about food. And Lisa's asking about more natural supplementation like spartone or grass-fed beef liver. I find there are sort of the pharmaceutical grade liquid irons. They're quite good at getting your iron up, but they have a risk of dental staining, so making your teeth slightly yellow. So we have to be really careful with that. And then I find spartone is probably the best of the non-pharmaceutical iron liquids. Floridix is another one, Moon Tonic. I find them okay, and it can be quite good for maintenance. They may not be that good for replacement. So maintenance is just to keep your iron at a certain level. Replacement is when you're actually trying to increase. So I wouldn't use spartone or those kind of things when I'm really trying to replace a mother's iron, knowing that the stakes are so high. Or use that liquid iron with something else and have that as your strategy. And then when we're looking at foods, we've talked about the iron absorption aspect of things. And so foods that are high in iron, obviously meats can be quite high in iron. Anything that makes the meat color dark, it's because of the iron content. So, and that's to do with the myoglobin. So all mammal meat has iron in that form. I think the important thing for me when you're eating meat is that it has to be really well cooked, so you can then absorb that iron more easily in that short part of the small intestine. So mince is always better than steak. If you don't have to chew, if there's slow cooked, it's going to extract that iron and make it more easily for that mother to absorb it. Seafood is interestingly very high in iron as well. Not all seafood, but especially small whole fish such as sardines, shrimps, clams. A lot of those types of oysters, also very high in iron. And anything where there is a concentration, so fish paste, for example, pate, animal livers can be also very useful in iron. And pate often comes from birds, and so when we're looking at goose pate or duck pate, that they can be amazing kind of superfoods for iron. And again, when we're looking at poultry, most poultry doesn't have much in the way of iron unless it's got that color, and so turkey leg is quite high in iron, as is duck. And when we're looking at sort of non-meat sources of iron, I think the superstars for me are legumes. And so, again, beans need to be really well cooked to release some of the phytates and binding molecules so that iron can then be more easily changed into an absorbable iron. So again, pressure cooking, slow cooking, and most beans have reasonable amounts of iron, but the superstars are white beans, lentils, and kidney beans. And they can be really nice additions to a mother's diet. Many other foods do have iron, mushrooms and seeds and nuts, and probably the superfood, I think, on that department are pumpkin seeds. So if you're wanting a little kind of nutritious snack that has that little iron boost, I'd probably go for that. And then everyone thinks about spinach. We all grew up with Popeye, and he was getting his strength from canned spinach. And spinach is an interesting one in a lot of these green leafy vegetables because it's really dependent on the soil that it's grown in. They've taken the best grown spinach and the worst grown spinach in terms of its iron content. It looks pretty similar, and there can be a 1,500-fold difference in the amount of iron from one type of spinach to another. So that's 1,500 mouthfuls of that rubbishy iron, or one mouthful of that good spinach. And just in terms of what we're kind of looking at. So just because a food has a label of being high iron doesn't necessarily mean that it's going to be that. And this is why I think it's so important to be buying local, talking to your people at the farmers markets about what they're doing from an iron point of view, from a soil point of view. What are they adding to their compost, those kind of things. And then fresh is always best for these. And then you want to cook those as much as possible. So your spinach, your kales, just so it releases the iron. You're going to lose some things, but you want the iron to be sort of more absorbable. One more question around food, and again, I'm not necessarily recommending that mothers eat their placenta, but it's a question that I get a lot, and there is good research showing that placental encapsulation and the mother eating that placenta increases her iron stores very significantly, and it's very easily absorbed, and it's probably the most iron-rich food that I'm aware of. When we look at something like beef liver, which is again high iron, that typically has just under 5 milligrams of iron per 100 grams. When we look at the placenta has over 75 grams of iron per 100 grams. So it's a 15-fold difference. So definitely the placenta could be considered as a superfood for iron. It is a bit of a hot topic, and there's a lot of debate over that, but I certainly wouldn't want to get in the way of a mother wanting to encapsulate her placenta for consumption, especially when you're looking at those iron numbers. And I'm sure there are many other benefits biologically from placental encapsulation that the more we study, the more we'll learn about. So that was a bit of a whirlwind tour of iron and why it's so important. It's a total bugbear that I have of mothers being left iron deficient, only slightly anemic, knowing how important it is for the mother, knowing how important it is for her child, and then how important it is for a mother's postnatal well-being. So this is why I keep saying this is the number one nutrient for mothers. My joke is that it's the first square of the hopscotch board, and when you play hopscotch, you have to kind of start with the first square and go through to work your way through the game. And so if you don't have high or sufficient levels of iron, it actually makes it a lot harder for all the other things to work. And so it's a very easy thing, I believe, to fix. An iron infusion can make a huge difference overnight, literally, in a mother who's got very low iron. Now, Kristen's asking here, what's a good ferritin level for a mum to aim for, maintain if she's breastfeeding 12 to 24 months plus? And so, the magic number for me is 70. If you can get your ferritin between 50 and 70, I'm really happy. Between 30 and 50, I'm like, okay, we need to do some work, but we won't need an infusion, and we may need to look at some sort of supplementation, especially once the menstrual cycle's restarted and you're breastfeeding. Suddenly your iron requirements go up. So Kristen's commented here, I had a woman taking a placenta after her 5th baby in 8 years. She was borderline anemic by 38 weeks, but birthed at home with no drama. At 6-week checkup, her ferritin had increased so much that she said, even my doctor was impressed it was taking from my placenta. Yeah, so again, there's just a case study around placental encapsulation really helping with iron levels. There's a reasonable amount of research in this, but because it's been a malaligned practice, I think we're going to be seeing it as something that the industry considers won't be supporting. And so, again, that is a decision that mothers need to make, and I really support them in that. I'll take any other questions. Christine's asking, is there such a thing as too much iron? Definitely. So iron overload can be a big problem in children. Children don't have the same regulation around iron, and so they can overdose on iron. So this is part of why you have these child-proof caps on all iron supplements, just to make sure your child doesn't chug down a whole bottle, because that's a very, if adults do that, they're just going to feel sick, but they're not going to become iron toxic. And then with conditions like hemochromatosis, where there is a gene that makes it hard for the body to down-regulate iron absorption if there's too much, you can definitely overdo iron. Interestingly, the hemochromatosis gene comes from the Vikings, and so these Nordic people who didn't have a lot of iron in their diet, and who probably lost a lot of iron through conflict, they can get a lot more iron out of their food, and they don't down-regulate their iron once they have sort of healthy levels. They keep accumulating iron. So yes, there is too much iron. I hardly ever see it in my recovering mothers. The only times that I have seen aspects of that is when mothers have been given too high an amount of an iron infusion, and then the body will regulate over time with that, but it can mean that the mother feels a bit rubbish for a few weeks if that's the case. So thank you for today. This is the first of my series of kind of a deeper dive into specific nutrients, and iron is the number one. Again, it's the iron reactor. It's what gives Iron Man his superpowers, and I think it's really such an important thing for mothers to help balance their being. And so you'll hear me talking about iron all the time. Kristen's asking, what's the earliest you'd test a baby, toddler, preschooler for iron deficiency? Is a blood draw the only way, or can you use a prick test? So there's no prick test that I'm aware of that you can really test iron. There are apps that people use in third world countries that will basically take a picture of the eye, looking at the white part, and they can get essentially what your iron reading is from that. And some amazing research from University of Sydney around looking at iron through those sort of things. I think it's only a matter of time before that's readily available for consumers, that you could actually just take a picture of your child's eye if you can get them to sit still long enough, and then get at least a screening test for iron deficiency. We have to do a blood test otherwise. So in terms of, there's not any time that's too early, really. That can happen with newborns, that they'll be taking iron tests. Again, you don't want to be doing an iron test unnecessarily, but I think if a child's very pale, if it's really struggling with sleep and gut issues, if a mother has been really deficient in iron, there may be some, or if the child's got parasites. So often with doing a stool test and seeing that child's got parasites, and it means that they're more likely to be iron deficient, knowing that iron deficiency in the third world is such an important issue for that contributes to malnutrition, iron deficiency. So to answer your question, Kristen, it really depends on what's going on for that child. There isn't too early a time, and you wouldn't typically do it as a screening test unless something was really up with your child. Have enjoyed today. If there are any more questions, please ask on Facebook, and I can always answer them at a later time. And enjoy your day. Thank you.
Finished? I want to talk to you about how we're saving it.